We now would like to represent complex numbers in a slightly different way based on what's called the Euler formula, which we write as e to the I theta is written as cosine theta plus I sine theta. Now, the way we do that is we use our Taylor formula expansions, where we can write e to the I theta as 1 plus I theta squared plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial plus dot, 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 dot. Now, if you notice, this is 1 plus I theta. I squared, that's minus theta over 2 factorial, which is just 2. I cubed is I squared minus 1 times another I. So instead of plus, it's minus I theta cubed over 3 factorial plus dot, 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 dot. And now let's collect the real and the imaginary parts. We have 1 minus theta squared, 2 factorial. The next term, I'll write it out even though we didn't put it there, 1 over 4 factorial plus I times theta minus theta cubed over 3 factorial plus the next term would be theta over 5 factorial, dot, 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 dot. And these are the separate power series for cosine of theta plus I sine of theta. And this Euler formula is one of the most important formulas in all of mathematics. And now we can represent this complex number. So let's write this as a complex number. Notice that its modulus is cosine squared theta plus sine squared theta to the 1/2. It's 1. So it's a complex number of unit length. And if I wanted to represent that on the plane, we have y, x, and now we have z here, e to the I theta, length 1. So this is length 1. And here, our angle theta. This is the modulus of z. So we can write the modulus of z times cosine of theta. And this is just modulus of z sine theta. That's y. That's x. And what we have here is, if you think about it, if we have the unit circle in the complex plane, depending on the angle theta, our complex number z can be anywhere on this plane when we restrict theta between 0 and 2 pi. Of course, theta can be greater than 2 pi, and we would just have a double value for any value of theta. Now, there's some very interesting things to notice here. First off, when theta equals pi over 2, cosine of pi over 2 is 0. Sine of pi over 2 is 1. And so e to the I pi over 2, well, that's, you can see it would lie on the vertical axis. It's a unit distance because we're on the unit circle. And cosine is 0, sine is 1. E to the I pi over 2 is I. In the representation, when we look at this number, e to the minus I pi over 2, well, that's minus I. And that's easy to verify this identity. So what we refer to theta in here, we call theta the phase. And this is a way to represent a complex number of unit length. Now the next step is to represent any arbitrary complex number on using our Euler formula.